so that hopefully it is more convenient for you when you revise. I have looked through your responses on SLS already. Okay, and based on the responses, I thought that I still want to go through certain things because feels like some of them still a little bit unclear. Okay, does everyone have a copy of the worksheet?
Yeah, I know. Yeah, you can bring something.
Okay, everyone got a copy? Okay, we'll look at example 1, which is a question I took out from your textbook. Okay, practice now 1A. This solely depends on your frequency table and cumulative frequency table. Okay, so in this case, what we have is a frequency table. Frequency table tells you, okay, what is the frequency for the interval. So in this case, we're looking at length of various insects. So the number of insects that are of length 25 to 30 millimeters, there's only one of such insect. Okay, in fact, to be more precise, it is 25 as either more than or equals to 25 or less than 30. Okay, but the thing is that from this frequency table, we do not know, okay, whether this exact one insect over here, is it actually 25, 30 or anything in between. We do not know what is the exact length itself. Okay, so from the frequency table, we can then construct our cumulative frequency table. And I think that earlier on in your SLS, there are a number of people who didn't get it correct, okay, or this similar question correct. So let's fill up this table. We need to pay attention to the very first one. We cannot assume that the first one means the frequency is 1. Looking at this interval, it says x less than 25. For this interval, it is x more than or equals to 25. Okay, so there are actually no insects that are lesser than 25. Okay, so the answer over here will be 0. So we must pay attention to what is the interval that we're given over here. Okay, which is a mistake that some of you actually made. Okay. Then for x less than 30, going back to the frequency table, the number of insects that are less than 30 millimeters, there is only one of each. Okay. Then looking at x less than 35, okay, looking at this interval, less than 35 would mean that anything that is below, okay, including and below this this interval over here, so 3 plus 1, so that means 4. Okay, then going down the list, we will have 10, 22, 32, 38, and 40. Okay, so what we do is just add up, okay. So, like for example, x less than 40, looking at the frequency table, less than 40 means from 6, add 3, add 1. Okay, that's why we will have 10. Okay, so things to take note. The first interval, okay, make sure you don't make assumptions. And then your cumulative frequency at the end, okay, this one must always be the total frequency. Okay, so this must always be total frequency, which the question did actually tell us. Right? Because right at the start, they told you there are total 40 insects. Okay, so over here, all the frequency are adding up to be 40, which explains why I can safely say there's no insect that's lesser than 25. Okay, so you can always do a check about your calculations when you look at this number and also the total frequency number that the question has given you. But it's not all the time that they give you this value. Okay, so that is just one way to check. Right? So using this table, okay, no way to erase this. Right? Let's look at how to answer the questions. Okay. So in part 2, part A, it says is using the table, the cumulative frequency table, find the number of insects which are which are less than 50 millimeters in length. Okay, so looking at part I, part A, there's a second page on the right which is blank. It's intended for your answers. Okay, so less than 50 millimeters in length. We look at this interval over here, less than 50. I don't need to go and count what is before already, because this value over here tells me exactly how many insects are less than 50 millimeters, and that will be 32. Okay, so number of insects equals to 32. Okay, so in answering this question for your SLS assignment, that was actually okay, well done. Okay, but I think it's about part B, part C that is not a little bit shaky. Okay, so find the number of insects which are at least 45 millimeters in length. At least actually means more than or equals to. So your cumulative frequency table over here, it is for length that are strictly less than. In order for us to find more than or equals to 45 milliliters, we can look at millimeters. We look at this row over here, which says x less than 45. But to find more than or equals to, we take 40 minus 22. But less than 50 millimeters in length. Okay, so at least that means more than 35, but lesser than 50. So that we're looking at these two rows over here, the number 32 and 4. That means that we're trying to find the in between. So we'll take 32 minus away 4. Possible to state the number of insects which are 50 millimeters or less in length. Okay, so 50 millimeters, sorry, keep saying millimeters. Okay, 50 millimeters or less, right, would mean less than or equals to 50. But this inequality over here is strictly less than 50. So we do not know how many insects are actually exactly 50 millimeters itself. Okay, so therefore we cannot actually see how many insects are there, okay, from this cumulative frequency table. And the way to explain it is to simply point out that this cumulative frequency table is a less than cumulative frequency table. Part 4 is where we actually combine the idea, the concept that we learned from probability with statistics itself. I mean, probability is still part of statistics as well. Okay, so in part 4, right, it says that if an insect is chosen at random from the 40 insects that there is, okay, find the probability that its length will be less than 50 millimeters. Okay, so the number of insects that are less than 50 millimeters is actually 32 of them. So the probability will be equals to 32 out of the total 40 insects. Then after that, making sure that we simplify our answer, either 4/5 or a decimal 0.8. Okay. Okay. Questions? Okay. I know that in the SLS lesson itself, okay, there was a video about constructing a cumulative frequency curve. Okay, you will not be tested in construction of a cumulative frequency curve. It's really more for you to understand how the curve comes about so that you know how to read it. Okay, because if you don't know how it gets constructed, then you would likely have a problem reading it. Okay, so let's take a look at part A, example 2. Yeah. Okay, again we are given a frequency table, okay, for certain intervals, and then in part A you need to find out the cumulative frequency for this table itself. Sorry, something is triggering my cough. Okay, so in this case, given that x less than 4 here, how we get this 7 is because from the original frequency table, we have 7 over here. Then for x less than 6, we are adding up 7 plus 11, that's why we get 18. So by the same process, okay, that we did earlier on, you will be able to calculate that this table shall be filled up with 35, 55, 65, and 70. Okay. Okay. So then using this cumulative frequency table, your curve is then being constructed. Since construction is not necessary, I have already constructed one using a computer for you. Okay, that's the diagram on the right. Okay, so how it's being constructed is that x less than 4, when we look at the amount of milk being 4, okay, I will plot a point at 7, okay, because our y-axis will be the cumulative frequency. Okay. Now, some things to note which I think the video didn't cover about reading of cumulative frequency curve. Alright, I want us to be very careful. While the end of the table 70 tells us the total frequency, okay, when we read the curve itself, we must look for the end of the last point over there, then we can see the total frequency. Don't always jump to the conclusion that the highest number that the y-axis can go will be total frequency. So only base it from the last point, okay, go over to the y-axis, then you can read that this value here is your total frequency. A very common mistake and the assumption that many people like to make is that the highest value is the total frequency. Okay? Then it causes all the calculation to be wrong. Okay? So I'm zooming in. Okay, so base it on the last point of the curve. Okay? I know that this, the printout that I've given given you is a little bit small. Okay, so therefore there will be a variation in how you read it. Okay, I'd like to give you about 10 minutes to work on part C and part D. Okay, maybe no need 10 minutes. Okay, I'll give you about 7 minutes first. Okay, 7 minutes. Read this graph. Okay, find out the values for parts, the answers for part C and D. Okay. It may vary a little because of the graph being small. Okay, but it shouldn't vary too much from you and your friend, between you and your friend. go through? Alright. Now, I hope that part A, okay, you are able to get the answer at least. Okay. Talks about, let me stop my timer first. Okay. Part A wants you to find the number of cows that produce less than 9.4 liters. So from the graph itself, we look for 9.4. Be careful of the scale that we have. Okay, it is actually 5 small squares to 1 unit. Okay, so 9.4 will be 2 small squares after 9, and you will find that it is actually about 49 or 50 cows. Okay, it depends on how you read it. Okay, when you read up, right? Okay, I think there is some flexibility, some allowance. Okay, so it's either you read it as 49 or 50. Okay, so either one will be an acceptable answer. Okay, if you want to read it as 49.5, okay, well, realistically speaking, we can't have 49.5 cows. Okay, but these values here are really just an estimate. Okay, because this curve itself, okay, from this point to this point, all these numbers here are estimated values because we do not know the exact data about the, this is about milk, right? Okay, about the amount of milk that the cows actually produce. Alright, so it is actually also okay if you leave the answer as 49.5. Okay? Well, realistically speaking, we can't have half a cow. Okay? But I think that most of us will either be getting 49 or 50. Then in part B, okay, we want to find the fraction of the total number of cows that produce at least 7.4 liters of milk. So being at least means that it's more than or equals to. Okay, so we first look for 7.4 liters first. Okay, reading upwards to the graph. Okay, you will likely be able to get about 29. Okay, so there are 29 cows that produce less than, okay, 7.4 liters of milk. So take note, 29 cows produce less than 7.4 liters of milk. The question wants at least, okay, so the number of cows that produce more than or equals to 7.4 liters of milk will have to be 70 minus away 29. There will be 41 cows producing at least 7.4 liters of milk. Okay. So the problem that some people actually make is that they forget, okay, what they're supposed to be finding, okay? They forget to take 70 minus 29 and they get 41. But of course that's not the answer yet because the question wants us to find a fraction. So that will be 41 cows out of 70. Okay? Any questions for that? Okay? Any question? Next, part C. Okay, part C says that we want to find the value of X if 70% of the cows produce at least X liters of milk. So X is the amount of volume itself, so that is a value to be found from the X-axis. Okay, we're looking at 70% of the cows producing X liters, at least X liters. So we find 70% of the cows first. That is 49 cows that will produce less than X liters of milk. Okay, wait up, 70 at least, sorry. Okay. Yeah. Okay. So 70% will actually, 49 cows will actually produce at least X liters of milk. Then after that, we take 70 minus away 49 to find 21 cows that produce less than X liters of milk. Let me cross check. That is here. Okay, then looking at 21 cows over here, going to our curve, okay, we look at where 21 is on the y-axis, okay, match it over to the curve, and then we can find out what is the volume of milk being produced by those 21 cows, okay. and that will be about 6.4 liters. So from the curve, we find that x equals to 6.4. Okay? And so 21 cows produce less than x liters of milk. The value of x looks like it doesn't. Yep. Okay. So then after last question, part 4. If 2 cows are chosen at random from 70 cows, so there are 70 cows in total, and then you want to select 2 cows that produce less than 9.4 liters of milk. So 9.4 liters of milk, right? Okay, it's either 49 or 50 cows that we have identified in our first answer already. Okay, so our probability would be found by taking 49 out of 70 cows in total. That is the selection of the first cow. There is no replacement because we are selecting 2 cows at one go. Okay, so we will multiply with 48 cows after taking away the first one. And then after out of 69 cows because we already took away the first one. Okay, because you're selecting 2 cows, no replacement at all. This is your probability. Okay, first selection, out of all the 70, you can choose out from the 49 ones. Okay, then after that, the second selection, 1 taken away already, so reduced by 1 in the numerator and denominator. Okay, if your calculation is this way, you will find that your answer is 56 over 115. Okay. If you chose 50 as an answer over here, then by all means, 50 over 70 times 49 over 69. Okay, so that's the other alternative. Okay, so that 35 over 69. If this is your answer. Okay, yep, Jasper. You don't get this part 4, huh? This part C, huh? Okay, so part C, it says that, okay, just read the question, it says the value, we want to find the value of x if 70% of the cows produce at least this amount. Okay, so we first find how many cows is this 70% first. Okay, so we count that 70% out of the 70 cows, that is 49 cows. In other words, 49 cows produce at least, okay, X liters of milk. Okay, so at least. Okay, but our curve is a less than curve. Okay, so if I were to, let's say, go and find 49 over here. Okay, if I go and read 49 and find out what is the volume here. Okay, what this 49 is actually telling me is that there are 49 cows that produce less than this amount. Okay, that's how we read the graph. For any number that I'm reading over here, like for example, if I read this one, okay, there are 25 cows that produce, in this case, about 6.8 liters. So that's how we read the data from the curve itself. But in this case, it is 49 cows that produce more than or equals to. So I need to do the reverse to find out how many cows produce less than X liters first. Okay, so I find 21 cows. And then reading from the curve itself, okay, for 21. Okay, then after I can read from the curve itself, okay, 21. And then you will find that it is actually 6.4 lah. Okay? Okay? So always remember, most of your curve should be less than or equals to. Okay? Likewise for your table. Okay? Question? Huh? The last part? Okay? The last part is your probability. We're looking at a pool of 70 cows. 49 of them, okay, based on your part A answer, is able to produce, okay, less than 9.4 liters of milk. Okay, so 49 of them can produce less than 9.4 liters. So out of these 49 cows, I take away one already. I'm left with 48 cows. Right? Okay? Because we are choosing 2 cows. Yeah, we're choosing 2 cows. That's why it's without replacement. Okay, so that's why in my second choice, I take away 1. Okay, and then my total cows also take away 1. That's why we multiply and get the answer. Okay? Questions? Alright? Last one. Okay, for cumulative frequency. Okay? This one I think you can turn to your textbook, page 84 to 85 for a clearer diagram. Because I just screenshot from the e-book, it may not be the clearest. Okay, I want you to give part I a try. Part I ABC. Okay, please do part I ABC now. I'll give you 6 minutes to work on it. If you find that the curve is not very clear in printing, suggest you look at your textbook. Monitoring him. Okay. You're done already. Right? Anybody still working on it? Okay, shall we run through our answers? Alright. Looking at part A, question says, okay, we want to find the number of adults who exercise more than 38 minutes daily. Okay, so looking at the curve itself, okay, this is a less than curve or less than or equals to curve, right? Okay, so more than 38 minutes. So we can go and read out where is 38 minutes first. Okay, that will be around here. Then after we find that from the curve, I can read 20 as a value. Okay, but the thing is that this 20 is for less than or equals to 38. Okay, so in order to find more than, I need to take the total number of adults, which is 60, minus away 20, get 40. Okay, so there are 40 adults that exercise more than 38 minutes. Okay, Jovian asked me a very interesting question just now. Okay, he asked me this question, for example, ask for number of adults that exercise more than 38 minutes. Okay, what if the question were to ask more than or equals to? Okay, just squeezing it here. Okay, what if the question asks more than or equals to, then will the answer still be the same or not? Okay, my reply to him is that no, the answer will not be the same. In fact, I cannot use this graph, okay, to get me my answer. Because this graph itself is a less than curve. You don't need to go and worry about the curve, whether is it a less than curve or less than or equals to curve. Okay, the wording of the question should obey by the consistency of the question itself. So if they say more than, then this curve is actually less than or equals curve itself. Okay, so you don't have to go and bother yourself about it now. Alright? Okay, so the question, if this is a less than or equals to curve, the question cannot be asking you more than or equals to. There's no way for us to actually solve it. Okay? So all we have to really take note of is more than, less than, okay? More than, we need to take the reverse, okay? To take the total minus away what we made from the graph. Okay? Then in part B, we want to find the percentage of adults who exercise at most 35 minutes daily. At most means less than or equals to. Come in. Okay, so therefore, reading from the graph itself, at most 35 minutes. Okay, at 35 is halfway through a square. Reading upwards, you will find that it is at about 16. Okay, so percentage wise, we get 16 over total 60 times 100%. Okay, and we get 26 and 2 over 3%. Next for part C. Part C asks for the value of T if 1/3 of the adults exercise more than T minutes. So we find out how many adults are there for 1/3 of them. That is actually 20 adults. So 20 adults exercise more than T minutes. Okay, maybe we write inequality more than T minutes. Right, but in order to read my graph, I need to know how many adults are actually exercising less than or equals to. So I'll need to take 60 minus 20 in order to find that number. Okay, and therefore our what did I want to find out? Sorry, I got lost. The value of T will actually be 47 from the curve. Okay. Next we look at part 2. Okay. article claims that 1 in 3 adults exercise at most 20 minutes daily. Okay, comment on whether the above data supports this claim or not. Okay, so 1 in 3 adults, that means a fraction of 1/3. Okay, they exercise at most 20 minutes daily. So we then first find out that how many adults are there. Okay, for this one out of 3. Sorry, let me just stabilize this. Okay, so reading from the graph itself, you'll find that there are 4 adults that actually exercise at most 20 minutes daily. Okay, and that fraction, okay, would actually be 4 out of 60, and we have 1/50. But the claim was that 1 out of 3, which is a fraction of 1/3. Okay, so sorry, just now I said that go and find first, right? Okay, I did the other way around here. Okay, so we find that the fraction is 1/15 and not 1/3, therefore the claim is actually not correct. Okay, so the fraction is actually 1 in 15 instead of 1 in 3. Okay. Yes, you do it the other way around. Okay, I was thinking about it, so give me a minute. Okay, so if you want to do it the other way around, in testing of the fraction itself, okay, we can find that 1 in 3 actually represents 20 adults in total. Okay, so from the curve itself, if you go and look at 20 adults reading, okay, 20 adults actually exercise at most 38 minutes daily. Okay, this is a value that you read from the curve itself. Okay, so let me just scroll through the curve. So if you look at 20 adults reading from the graph, you find that it's about 38. Okay, so the data does not actually support the claim, as 1 in 3 adults actually exercise at most 38 minutes and not 20 minutes. So this is another way that you can go about answering the question. Okay? Actually, is that okay? Okay, then now, part 3. It says that if the adults are selected selected at random from the 60 adults, we want to find the probability that both adults, so again it's a selection of 2 adults that exercise at most 66 minutes daily. Okay, so reading from the curve, at most 66, that means less than or equals to 66, we just have to simply read it, okay, and we find that it is actually at about, sorry, you not see from very far, about 59, right? Okay, so from the curve at 66, you will read that it is about 59. So actually there are 59 adults that actually exercise at most 66 minutes. That is for the first adult that you are choosing. Okay, then for the next adult, you have to deduct 1 from that number. Hence, in part 3, the probability would be 59 over 60 times the second peak will be 58 over 59, and that is 29 over 30. Okay, so that's how we calculate the probability for part 3. Okay? Now another very important skill in terms of cumulative frequency curve, other than knowing how the cumulative frequency table translates into a curve, we must be able to translate from the curve back to the table as well. Okay? Should I continue, Sishen? Wani, I don't know what's that rolling in your hair. Can you please take it out? Not sure why you need a fork in your hair. Okay? So in part 4, right? Okay, it says that complete the following cumulative frequency table for the data given in this cumulative frequency curve. So how we go about translating the curve information into this is that for the first interval, we have x less than or equals to 0. So when it is at 0, we see that the curve happens to start at 0 as well. So the number of adults will actually be 0. Okay. When it is x less than or equals to 10, reading from the curve, we see that the value is a 1, so therefore it is a 1 here. We move on to x less than or equals to 20, okay, and that will actually be a reading of 4. Right? Observing the pattern of the intervals, they are always 10 units, differing by 10 units. So the next interval we're looking at will be x less than or equals to 30. And from the curve, we will find that the value is 11. Okay? We do the same for the rest, all the way until it reaches the interval of x less than or equals to 70. And at x less than or equals to 70, it has to be 60 because for cumulative frequency table, this last value must actually be your total frequency. So if you read from the curve, you will find that this is 23, 46, and 56. Okay? So we can only translate from the curve itself into the cumulative frequency table. So in the cumulative frequency table, our intervals are always bounded at the upper end only. Okay? So strictly less than or equals to. Right? Then from this cumulative frequency table, moving on to the frequency table itself, okay? In order for us to know what is the, oh sorry, I think I left, sorry, I typed wrongly here. It shouldn't have the word cumulative. Okay, so the header should just be frequency. For us to find out, okay, how many adults that exercise between 0 to 10. Okay, looking at this, 0 to 10 will mean that it is actually between these two. So therefore, it is just one adult that exercise between 0 to 10. Because this one is less than or equals to 0. Okay, so 0 to 10 is just one adult only. And then 10 to 20. 10 to 20 is in between. There are actually 4 adults that exercise less than or equals to 20. But out of these 4, one of them actually less than or equals to 10. So I need to take 4 minus away 1 in order to figure out the value of 3. Okay. Moving to the next one, we have 20 to 30. So 20 to 30 is in between over here. Likewise, we take 11 minus away 4 in order to know what is the in between. Okay, and that will be equals to 7. Okay, so we work out the same way for the rest, and you will find that the answer will be 12, 23, 10, 4, and 0. Okay, so we constantly just take the upper bound value minus away the lower bound value that you can read from the cumulative frequency table. So upper bound minus the lower bound. So let's say I want to find between 40 and 50, I take 46 minus 23. Okay? The reason for me to choose this question to run through is because, okay, I want us to actually recap how do we find out the value of mean, median, and mode. Mean, median, and mode are skills that you have learned in Sec 2, which unfortunately I know some of you told me you never learned before. Okay, which I know is impossible. Okay. I don't recall that mean, median, and mode was assigned to you. I think it was taught to you or assigned to you, okay, after the end of your exam, or when you were in Sec 2, okay, because I think COVID-wise and all that, they removed the mean, median, and mode from testing for the end of the exam that year. Okay. So regardless, okay, looking at part B now, we want to find the estimate of the mean amount of time that the adults exercise daily. So based on this data itself, I can only know, okay, from all the information that we are given, that only one adult exercise between 0 to 10. For this one adult, I do not know whether they are exercising 0 minutes, 1 minute, 2 minutes, 2.3 minutes, 2.5 minutes. The exact data I do not know. So that's why I can only go about estimating. And how do we estimate when the data values are given in an interval? Is that we need to find out what is the mid value. Okay? So we create a second header, mid value, where I take the upper bound minus the lower bound. Oops, sorry, not minus but plus. Okay? And divide by 2. And I will find that it is 5. Okay? So I continuously do that to find out what is the mid value in these intervals itself. Okay? Do not take for granted that it is always the one right in the center, okay, that you always think that there's a pattern going on. It could be irregular intervals. That means they are not of the same length, okay, for the interval. So always follow by the rule where you take the upper bound plus the lower bound divided by 2 to find the middle value. Okay? So the mid values are all these values here. We use that as a data reference point to calculate our mean. Okay? So for mean, we have one data, okay, one frequency, one person that has an estimated time value of 5 minutes. Then we have 3 adults that have an estimated time value of 15 minutes. Okay, And then after that, 25 times 7. Okay? Multiplying will find for us the total time, the total data value. Okay? You can plus dot 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 in your working, but in the end when you press your calculator, make sure you press correctly. Okay, all the way to the last one, which is 75 minutes for 0 people. Out of a total of, in this case, 60 people, if you like to press the numerator separately from the denominator, your numerator will add up to be 2565 out of 60, and that is a mean value of 42.75 minutes. Okay? Sorry, I overlooked the time. Okay, so that's for part C. Like I mentioned earlier, we can only estimate the mean because we don't know the exact time. Okay, that's why I will choose to take the mid value. Okay, we need to have a consistent rule. Okay, so therefore we take the mid value of each range or each interval. Okay, maybe instead of range, I think it's best to say because range has a certain meaning to it in statistics. So cannot anyhow use the word range. Okay, as a representative x value for that particular interval. Okay. Okay, homework exercise 3A, question 6 and 10, just 2 questions only. Okay, this one just let it be due when school reopens. Okay, what do you have now? Oh, okay. Are you supposed to go somewhere? I'm so sorry. Okay, I will be releasing on Google Classroom my consultation slots over the March holidays. It's a booking site, so if you need consultation, you can always book it over there. Okay, instructions are all found Google Classroom. Okay? Okay, I don't want to hold you back. Really apologize. Please apologize to your teacher for me